Hello, Ethan. Alrighty, so it is 5 o'clock, so thank you guys to those who have already arrived, and I anticipate other people will be coming a little bit later, so I'm just going to go ahead and get started for now. And today we're doing the Algebra Workshop, which is really, really cool. So if you guys have questions at any time or anything like that, always please feel free to unmute or type in the chat if you are confused about anything or anything like that, because I want you guys to understand most or all of the things that I'm saying today, even though we're going to be going through some pretty difficult problems. So yes, and if you want to, you can also check out my website and other things like that if you want to learn about other things that I'm going to be doing in the future. So that would be really cool as well. So before we get into any of the math for today, I just wanted to say that algebra is going to be a little bit different than some of the other things, some of the other subjects, because algebra is there are many questions on the AMC 8 about algebra in general, and there's not that many hard things you need to know. There's not many formulas for algebra or specific concepts that you're going to be learning. A lot of it is just like thinking and knowing how to just do math, I suppose, and getting better at doing that. I know that sounds kind of dumb, but it's pretty true. So I'm going to go ahead and get started with our first topic for today. And our first topic is easy equations. And what I mean when I say the word equations is not like necessarily y equals mx plus b or something like that. Like not necessarily like what you think of in the traditional sense, like something like this. It's a lot more of just basic operations and interpreting word problems is the main thing that I'm talking about when I'm saying equations. So let's take a look at what this specifically means. So simple algebra equations like 1 variable, 2 variable, 3 variable systems. This could be one of the things that we're doing, but a lot of times it has to do with word problems and generally just interpreting the words to mean something and solving a problem after you interpret those words. All right. So how this looks in an actual problem is, let's look at AMC 8 2022 problem 5. So we're starting off not that difficult, hopefully, because it's just a problem 5. And the problem says Anna and Bella are celebrating their birthdays together. 5 years ago, when Bella turned 6 years old, she received a random newborn kitten as a birthday present. Today, the sum of the ages of the two children and the kitten is 30 years. How many years older is Bella than Anna? Okay, so 5 years ago when Bella turned 6 years old. So Bella is, let's say Bella, like B stands for the age of Bella. So Bella is 11 years old right now. And then Anna is something we don't really know. And 5 years ago, she received a newborn kitten as a present. So the age of the kitten was 0 5 years ago. So that means that now the age of the kitten is going to be 5. Right? Because 5 years ago, it was a newborn. And today the sum of the ages of the two children and the kitten is 30 years. So A plus B plus K is going to equal 30. So that means that A has to be 14, because 30 minus 11 minus 5 is going to be equal to 14. So now, how many years older is Bella than Bella is Anna? So 14 minus 11 is going to be our final answer, and that is going to be 3. So hopefully that was a pretty simple problem to get us started off today. Hopefully you guys can understand how to do that pretty easily. And the main thing that you're doing when you're doing this problem is you have to figure out what you should assign variables to and just interpret the words of this problem, because this one's not really that difficult, but they do get a lot more difficult in terms of how to interpret them later. Okay, now I need to move myself because I'm a little bit too big. And this next problem says AMC 8 2023 problem 10. Harold made a plum pie to take on a picnic. He was able to eat only 1/4 of the pie, and he left the rest for his friends. A moose came by and ate 1/3 of what Harold had left behind. After that, a porcupine ate 1/3 of what the moose left behind. How much of the original pie still remained after the porcupine left? So he ate 1/4 of the pie. So that means that we had 3/4 of the pie left after Harold came. So then a moose came by and ate 1/3 of this. So that means that the moose left 2/3 of this. So after the moose came, we had 1/2 of what Harold left behind. After that, a porcupine ate 1/3 of what the moose left behind. So that means that we had 2/3 left of what was this, and this is going to be 1/3. So once again, we really have to interpret all of these words really, really carefully, because it's not easy to see how this problem can be interpreted, because it's a lot of words and stuff like that. But once you do all of that, you realize that the final answer is going to be 1/3. So that is our answer for the second problem. Okay. Hopefully that makes sense. The most important thing to emphasize on this slide was that we were talking about a lot of word problems, and interpreting the words of these problems is not always easy, but there's many problems like this on the AMC 8, and they go up to levels much higher than problem 10. Like, for example, I've seen some problem like 12s, problem 19s, stuff like that. That it's very similar to these kinds of problems, so they just get harder in terms of interpreting the problems and the math you have to do. But yeah, it's really important on the AMC 8, even if it seems kind of trivial and easy right now. But 1 variable, 2 variable, 3 variable systems, they are going to be used sometimes, but not in these problems. So we can go on to the next thing. Okay, so this is something that's pretty unique to the AMC 8. I guess maybe you'd see this in math count sometimes, but sometimes in the AMC 8 they have problems that you need to use estimation for. So estimation is kind of annoying because you're not really certain if you have the right answer or anything like that. And estimation is best learned by doing problems, right? And as you'll see, because this is algebra, but a lot of the concepts that we're going to be going through are best done by doing problems instead of whatever else you would do to help with math. I don't know, like learn concepts and stuff, because there's not too many concepts for algebra, right? So you have to make sure your estimations are not too extreme, okay? So this is not immediately apparent what this means until you start doing problems, but basically you have to be semi-accurate with your estimations. You can't just do something that pretty obviously won't work. So I'll show you how this applies when we're doing our next couple of problems. So AMC 8 2001 problem 5 says, on a dark and stormy night, Snoopy suddenly saw a flash of light. 10 seconds later, he heard the sound of thunder. The speed of sound is 1,088 feet per second, and 1 mile is 5,280 feet. Estimate to the nearest half mile how far Snoopy was from the flash of lightning. Okay, so first of all, I don't know if you know anything about the world, but the speed of light is like really, really fast. So like, it doesn't matter at all how fast the speed of light is. We can think of it as instantaneous. And now that I think about it, that's pretty incredible, because you have to assume that for this problem. So this problem's low-key not that easy, but yeah, so we don't even have to think about the speed of light. So, 1 second. How far is Snoopy from the flash of lightning? Okay. 10 seconds later, and we have 1,088 feet. So times 10, and this is going to equal 1,088 zeros. So this is how far Snoopy was from the sound of the thunder. Okay, and 1 mile is equal to 5,280 feet. So instead of doing this actual division, we can just see that 1 mile is approximately, and this is where estimation comes into play, 5,000 feet. So it's approximately 5,000 feet. And we can say that because we only have to calculate how far Snoopy was from the flash of lightning to the nearest half mile. So it's really not that precise of a measurement. So 5,280 feet, 5,000 feet, this is still going to give us pretty much the same thing. And dividing that by this, we get that it's approximately 2 miles. So, and that indeed is going to be our correct answer. 2 miles is the final answer for today. So I think you guys see there that if you made like too extreme of a estimation, it would be bad. But because we only estimated by decreasing by 280, it's really not that bad, and nothing else happens. But like if you had decreases and be like, oh well, 5,280 feet is pretty close to 10,000 feet. That's when your estimations become too extreme, and we'll see a little bit more of that in this thingy right here. Oh, and I was supposed to at the answer choices, but I didn't get around to that. So, oh, this problem's going to be pretty difficult without answer choices. Okay, we can just go about it anyways and get something pretty close to the answer. Okay, so after traveling 292,526,838 miles, it landed on Mars in Jezero crater about 6.5 months later. Okay, which of the following is closest to the rover's average interplanetary speed in miles per hour? So we have a rover that's traveling, and it traveled this many miles in 6.5 months. Which of the following is miles per hour? So we want the amount of hours in 6.5 months. So 24 hours in a day times 30 hours in a 30 days in a month times 6.5 months in however many thingies we want. So 720 times 6.5. So if you multiply this by 2, the 6.5, and divide the 720, this is going to be the exact same thing. So 360 times 13. Okay, this is the same thing as this. Except for not with the -2. Okay. Oh, I don't know if you guys can see that very well. Sorry. Basically, everything goes back to 360 times 13. Okay, so 360 times 13 is going to be how many hours the rover spends traveling. So it's 13 times 36. You guys can do this if you want, but I'm just going to do it a little bit faster here. 108, and this is going to be 400,680 total miles. Hours. And then this is the amount of miles. So we can kind of estimate the number of miles to be 300 million. Okay. And then we can estimate the amount of hours to be 5,000. And when you do this estimation, the answer turns out to be, hold on, 6,0,0,0. Wait, I think that should be right. Hold on. 1, 2, 3, 4, 1, 2, 3. Yes, this should be the final answer. And I know this problem's a little scuffed because we didn't have the answer choices, but if you look at what the answer thing is, 6,000 was the correct answer. But the key thing to notice here is that notice that we didn't make our estimations too extreme. Now this one is kind of extreme actually because we did increase by like a factor of 10 over 9, about something like that. So there's like a 10% increase in the number from 4,680 to 5,000. So that's kind of a lot, but this one over here especially is not very much of an increase. That was only like a 0.1%, I don't know, something really low. So just make sure that when you estimate things like this, and if you see a problem like this on the AMC 8, which is actually pretty possible because, look, this was just like a couple of years ago, you have to be careful with your estimations and not make them too big. Okay, now we're going to move on to rates problems. Okay, so rates is D equals RT. Hopefully you guys know what this is. And this is distance equals rate times time. Okay. Distance equals rate times time. And this means that, let's say we wanted to go 1 mile. Let's say we wanted to go 1 mile. And our rate was 1 mile per hour. Then we would have to go 1 hour. See, this is actually really intuitive if you think about it. 1 mile times 1 mile per hour equals 1 hour. This makes a lot of sense, right? But let's say we wanted to go 20 miles and we were going 5 miles per hour. We would have to go 4 hours. So there's a lot of different scenarios like this, but distance equals rate times time is a very, very fundamental equation if you guys don't know it. So, yes. And I don't think I really fully understood what distance equals rate times time meant until like 8th grade or something, because it's really like intuitive. It really makes a lot of sense, like just naturally. Because when you see problems like what I just said, 20 miles in 5 miles, you just automatically say 4 hours. And you don't even think about sometimes the fact that the 4 times the 5 is equal to the 20. You just immediately jump to the answer. So that is very crucial for this thing in general, that we're realizing that distance equals rate times time. But if you can think about it not with this equation, that's okay too. If you just have a strong intuition and know what to manipulate, that's okay too, because that's kind of what I did when I was in middle school. So Quing, I don't know how to pronounce that, drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? Okay, so 15 miles at an average speed of 30 miles per hour. So that means in that if we drove for 15 miles at 30 miles per hour, we would have to have driven 1/2 of an hour. Okay, so we've driven 15 miles in 1/2 of an hour. Okay, so now how many additional miles will we have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? Okay, this is where it gets pretty tricky, okay? So let's say that we drive for X more hours. X hours. Okay, so what we know is that we have 15 miles, I believe, right? Yeah, 15 miles in 1/2 of an hour. And we want to get to 50 miles per hour by driving 55 miles per hour. So 15, let's say that we drove 55 miles per hour for X hours. That means that we will have driven 15 plus 55x miles, and we will have driven 1/2 plus x hours. Yes, and this is going to be our rate because this is miles over hours, or miles per hour, or you can think of it as distance over time, and we're trying to make our rate equal to 50. Okay, so now we can multiply both sides by 1/2 plus x, and when you do this you get 15 plus 55x is equal to 25 plus 50x. And this is just simple algebra now. So 5x is equal to 10, or x is equal to 2. And seeing that x is equal to 2 is going to give us our final answer of 2. No, not 2. Our final answer is going to be at 55 miles per hour for 2 hours. So that's going to give us 110 miles. And that is our final answer. Okay, so now that you see that the answer was so low, you realize that we probably didn't actually need to go through all these steps, and you probably could have just solved the problem without specifically going through all of these things. You could have just said, I'm going to see what happens when we have 1 hour, what happens when we have 2 hours, and you could have guessed and checked like that, but this gives us a nice systematic way of solving the problem. Alright, now we are going to move on to problem 15 of the AMC 8 2023. So Vishan walks 1/2 mile to get to school each day. His route consists of 10 city blocks of equal length, and he takes 1 minute to watch each block. So 1/2 mile. I'm going to stop right here. This is where I stopped, and I'm just going to read the rest of the question later. So 10 city blocks of equal length, and he takes 1 minute. So he takes 10 minutes to do the entire thing. So in miles per hour, this is going to be 1/6 of an hour, right? So his miles per hour at the beginning is going to be 3 miles per hour. Alright, today after walking 5 blocks, Biswam discovers he has to make a detour, walking 3 blocks of equal length instead of walking 1 block to reach the next corner. So there's no drawing because there was in the original problem, but basically he goes like this instead of going like straight across right here. So that's going to add 2 blocks because we're going 3 blocks instead of 2. So we're adding 2 blocks. Okay, so now we have 12 total blocks, and he needs to reach school in the same amount of time as he did before. Yeah, he still needs to take 1/6 of an hour, but now it's going to take him a little bit longer. So usually he takes 1/2 mile. Okay, I'm going to go here. Usually he takes 1/2 mile for 10 blocks. So that means that each block is going to be 1/20 of a mile. Or what happens is when you have 12 blocks, So block is equal to 1 over 20 miles. So 12 blocks is now going to be equal to 3 over 5 miles. Okay, so 3/5 of a mile, and from the time he starts his detour, at what speed in miles per hour must he walk in order to get to school at his usual time? So now he needs to walk 3/5 of a mile in 10 minutes, or 1/6 of an hour, right? So 3/5 of a mile divided by 1/6 of an hour, and this is going to be equal to 18 over 5 miles, or 3.6 hours, I believe. Oh no, sorry, 3.6 miles per hour. So yeah, 3.6 is now going to be our final answer. And yeah, so that's how we work with this rates subject right here. Okay. If you guys have any questions or anything like that, you can always type them in the chat, which would be great. But if you guys are not, I see that we have a couple less people than we used to have. So thank you guys so much for sticking along. And if you have any questions, you can type them in the chat. If not, you can like write something like good or something like that, like Jalen just did. So yeah, that would be really great. If you guys do have questions, that would be great if you could ask them. And I did just want to say that we will be getting to some harder material later if this is a little bit easy for you guys. But thanks for sticking with me here. So the next topic we're going to cover today is sequences, okay? So sequences, there's a lot of different things to do with sequences on the AMC 8, and it's kind of a vague subject that I'm starting covering right here. But basically, sequences are going to force you to find patterns and apply them to solve the problem. So this can take the form of a bunch of different things, but I will just show you some things that will do this. This is not like arithmetic sequences or anything like that, or geometric. That's not what I'm talking about here. Those kinds of sequences will not necessarily be that common on the AMC 8, so I'm talking more about just general sequences. Okay, so the first question is an AMC problem 8, so it shouldn't be hopefully that difficult for you guys. And it says, what is the value of 1/3 times 2/4 times 3/5 times all the way until 20 over 2022? So 1/3 times 2 over 4 times 3 over 5 times 4 over 6 all the way until 20 over 22. Okay, so notice that the 3 and the 3 over here can cross out. That's because like when you're multiplying fractions, you just multiply the numerators by each other and then the denominators by each other, and then you like can just cross them off, right? So 4 can be crossed off with 4, 5 can be crossed off with 5, 6 can be crossed off with, all the way until 21 over here also can't be crossed off, but we can cross off 19 and 18. So 19 can be crossed off. Okay, sorry, this is 17 over here. 20 can be crossed off, and with the 20 over here, and 20 and 22 cannot be crossed off, as well as 1 and 2. So our final answer is going to be 2 over 21 times 22, and when we simplify this, you get 1 over 231. Oh, 1 second. 1 over 231. So that is our final answer for this problem. So that's something that happens pretty common in multiplication series like this, where you multiply all of the things and then you divide by, it's like a lot of telescoping things, so you have to cross off things that cancel out, and in this case it crosses off very nicely and you get a final answer of 1 over 231. Okay, now on to the next problem. The problem says the letters P, Q, and R are entered into a 20 by 20 table according to the pattern shown below. How many P, Qs, and Rs will appear in the completed table? So basically what the table shows is something like this. It doesn't show the whole table, but what it shows is a P in this corner. And 1 second, that was not the best way to draw that. Hold on. So it shows an incompleted table, but it shows some of the grids, and I'm just going to draw a little grid for us here because this is what's drawn in the problem, and they fill out the grid by going like diagonally. So we have a P here, a Q here, an R here, an R here, an R here, and so on and so forth, because then there's a P, a P, a P, oh, oops, sorry, a P here, a P here, and then there's a Q here, and so on and so forth. So that's sort of how this grid works, and we're asked to figure out if this continues all the way until the whole 20 by 20 grid is figured out, because it extends diagonally, extends vertically, extends horizontally. How many P's are there going to be in the diagram, how many Q's, and how many R's? So let's just figure out, let's focus on one thing. Let's focus on these P's. So in the first diagonal, because they're sort of organized by a diagonal, as you see. As you go down this diagonal, all the R's are the same, all the Q's are the same, all the P's are the same, all the P's are the same up here, all the Q's are the same over here. So it's organized by a diagonal, and in this first diagonal, we have a P, and so we have one P. And then we have 4 P's in the next diagonal. And then we have, it looks like we're going to have 7 P's in the next diagonal, if you think about it, because we keep on increasing the amount of P's we have. And then we have 10 P's in the next diagonal, and after that it's going to go down from there, because when we have 10 P's, that means we're going to be on the main diagonal, because there's, oh wait, sorry, that's very wrong, my fault. Ignore what I said. So then we have 13 P's, because it's just going to keep on going up like by 3 like this, 16 P's, 19 P's, and then whatever has 20 in it, whichever one of these, Q or R, the other one will go down after that. So instead of having 22, we're going to have 18, because it's going to go down after the 20 occurs. So then we have 18 P's, 15 P's, 12, 9, 6, and 3. So this is pretty difficult, but when you add up all these numbers, you can group them into things that are easier to work with. So the 1 plus 9 equals 20, 4 plus 16 equals 20, 7 plus 13 equals 20, and the 10 is also equal to 20. So we have 70 total P's, and then the 18 plus the 3 is equal to 21. This is equal to 21, this is equal to 21, plus 63. So we have 133 total P's. Okay, so now we're going to have to figure out how many Q's and R's there are. And remember that they're going to sum up to a total of 400. So the Q's are going to go 2, 5, 8. 2, 5, 8. Oh, actually, let's start with R's first, because that's what I want to do. Because I think the R's are going to be a little bit more useful for us. Oops, sorry about that one. I don't know how that happened. There we go. Okay, so let's do the R's, okay? So the R's start with 3, 6, 9, 12, 15, 18, and what you realize is that after 18 we have a 19, because we go down from 20, and it's going to be the exact same as what we had for the P's. It's just going to be in the opposite order. So we have 133 R's, and that means that we have 134 Q's. So this is the final answer, and if you look at the actual problem, that's exactly how the answer choices are laid out. So this problem is a little bit strenuous, but hopefully you guys got the main idea of the problem and understand how to keep on going and complete these kinds of problems for yourself. So yeah, next we are going to be talking about minimality and optimality. So hopefully you guys know what this means. If you don't, that's okay too. Minimality just means like we're trying to minimize something, right? So make it as small as possible. Small as possible. And optimality means make as big as possible. As big as possible. Okay, so minimizing and optimizing things is critical to many problems, and not just the ones that we'll see here, many other ones as well. And you will later learn inequalities, but for now, these are these strategies are not hard skills. Okay, so what I mean by that is there's many problems where this happens in the AMC 8, and these are not the only examples of that. And later you'll learn inequalities maybe in competition math, which is really interesting because it's other ways of finding the minimum and the maximum, specifically of very algebraic equations. But these strategies are not like hard skills. They're just things that you can do to figure out all of these problems. So there's no formulas or anything like that for these problems. You just have to sort of work through things and figure out what's working and what's not. So I'll show you guys examples now. So AMC 8, 2024, problem 14. What is the distance of the shortest route from A to Z? From A to Z, okay? And what it is a bunch of different things with numbers on them. So we can go from A to X to M for 2, and we're just basically just going to have to find the whole thing, and it's going to not be the easiest thing, I believe. But I think we can get through it together. Okay, so the first thing I noticed is that this 8 right here is completely useless because it's faster just to go from the 5 and the 2. I kind of covered up the 2, but hopefully you guys remember that it was there. So it's always faster to go to the 5 and to the 2. And yeah, so this route is kind of not useless. And same with this route up here. This 10 is completely not useless because it's faster to go from X to M with the 2 that was there than to go X to N and then M to Y, because that would be a total of 8 instead of going X to Y, which would just be straight up 10. And the same thing goes for this one right here. This route is useless because you could go from M to Y for 6 and then Y to Z for 5. And then the Y to the Z is also going to be useless because Y to Z is 5 and C to Z is 10. So now this M over here is also going to be useless because this is 25, which is greater than the 6 over here, the 5 over here, and the 10 over here. So that means that what we want to do is we want to go from 5 to 2 to 6 to 5 to 10. So that, adding up all of those, is going to equal a total of 11 plus 8. Oh wait, hold on. 28. That's going to be our final answer. So, yes. And what you sort of notice here is that, yeah, Jalen got it exactly right in the chat. So, 28 is going to be the final answer. And 28 is what you get when you sum up all of these, and you notice that we wanted to optimize this thing, and in order to do that we had to figure out what was bad for our optimization. So we wanted to take everything that was lower and leave the things that were higher. But sometimes this gets a little bit harder, so let's look at AMC 8 2023, problem 18. Greta the grasshopper sits on a long line of lily pads in a pond. From any lily pad, Greta can jump 5 pads to the right or 3 pads to the left. What is the fewest number of jumps Greta must make to reach the lily pad located 23 pads to the right of her starting point? Okay, so we need to make the amount of pads she jumps as small as possible, and we want it to be 23. So what I'm thinking is that we jump a multiple of 5. We will jump a bunch of multiple of 5s because we want to do that as many times as possible because we want to jump to the left as little as possible, right? So let's take multiples of 5, okay? And we'll take a bunch of them and go somewhere past this, so like 25, for example. And then we'll take a couple 3 jumps and we'll go backwards. And if we take this approach where we just do our multiples of 5 first, then we're going to end on a multiple of 5. And that makes sense because if we want to do all of our multiples of 5 first, then that's how many multiples of 5 we're actually going to do, and we're going to do no more. So that means that if we jump to 2025, then we only have to do jumps of 3 to the left after that. So 2025 will not work. 2030 now, if we just do jumps to the left now of 3, then we would get to the 2027 pad, the 2024 pad, and that wouldn't work either. So now, if we go all the way to the 2035 pad, then we can go back to the 2032 pad, back to the 2029 pad, the 2026 pad, and finally the 2023 pad. So now we have to figure out how many times we did this. Well, we jumped to the left 1, 2, 3, 4 times. So 4 plus 2035 divided by 5, and that's going to be 407. Dividing by 5 is usually not that hard, so hopefully you guys can understand how to do this. And if you don't, just do long division, and that should be good for you guys. So 407 plus 4 is going to be equal to 411. And that is the final answer. So, yes. Basically, what you really have to realize is that jumping your multiples of 5 all the way first is going to be what's useful. And I see some of you guys put answers in the chat, so that's pretty good. If you guys could just give me another thing. If you have questions, please feel free to put them in the chat. If you don't, just say good and I understand everything, and maybe like go faster or don't go faster to see if I should speed up the pace, because at this rate I'm pretty sure we won't get through everything, which would be pretty sad. But once you guys do that, I think I will keep on going here. Alrighty, okay. The next thing we're going to be covering is mean, median, mode, and range. Okay, so mean, median, and mode are different measures of the middle of a set. So they're all really trying to say the same thing, but they do it in different ways, okay? So if you don't know what this is, mean is equal to the average of the numbers. Median is equal to the middle, and by that means let's say we have the data set 1, 2, 5, 8, 10. The median will be the 5 one because the 1, 10, 2, 8, and 5 is the middle one. Okay, so now the mode is the most common one. So like let's say our set was, then 1 would be the mean because there's 2 ones in this one. And then range is a different thingy. And range is a measure of the spread of the data set. So in this data set, 7 minus 1 would be the range. 7 minus 1, and that's going to be 6. It's like the difference between the greatest one and the smallest one. Alright, so now let's look at AMC 8 2025 problem 14, okay? A number n is inserted into the list 2, 6, 7, 7, 28. The mean is now twice as great as the median. What is n? Okay, so one more thing I didn't explain about the median is that when there's an even amount of numbers in the set, let's say we have 1, 2, 3, 4, 5, 6. Well, what is the mean in the median in this case? Well, the 1 and the 6 cancel out the 2 and the 5, and then we're left with these two numbers in the middle, and what you do is you take the average of them. So you get 3.5 as the median in this case. So now, what's going to happen is we're going to have 6 numbers, so we are going to have this average type of median over here. A number n is inserted into the list. The mean is now twice as great as the median. So since the mean is great, I think we're going to want to add a pretty big number. So something like bigger than 7. Bigger than 7. And I see someone who maybe put an answer in the chat already, and we'll see if this is correct. So that will be pretty cool to see. So the median is going to be 7. That makes the most sense, which means that the mean is going to be 7 times 2, or 14. And the reason why the median is 7 is because when you add another number to the end, then you get something that, when you add another number to the end, that means that the 7 and the 7 are the two middle numbers. So 7 is the median, and 7 times 2 equals 14 is going to be the mean. So we have 9 total numbers, remember, so 14 times 6, oh sorry, not 9, 6 numbers. So 14 times 6 is going to be equal to 84. So now all we need to do is that we know that this is the sum of all of the numbers, so we need to subtract 2 minus 6 minus 7 minus 7 minus 28. And doing all of this, all of these numbers are equal to 50 combined. So 84 minus 50 is going to be equal to 34. So yes, 34 is indeed the correct answer. Yeah, so that's how we do median in that case, and I'll just give you guys like a couple more seconds to look at this work before I erase it because we need more space for the next problem. All right, so the next problem says two integers are inserted into the list 3, 3, 8, 11, 28 to double its range. The mode and median remain unchanged. What is the maximum possible sum of the two additional numbers? Okay, so to double its range, the mode and the median remain unchanged. What is the maximum possible sum of the two additional numbers? All right, 3, 3, 8, 11, 28. So we know that the median and the mode remain unchanged. So that means that this 8 right here is going to stay the median. So that means that we have to put one number on this side of 8 and one number on this side of 8. And we want to maximize the sum of the additional numbers. So since the mode stays the same, we can't add another 8 to our list. But we want to make that number as big as possible because we want to have the sum as big as possible. So we want to add a 7 right here. So that's what we're going to do. We're going to do 3, 3, 7, 8. And then our other numbers are 11, 11, and 28. And we want to double the range. And before, the range was 25. So now we want the range to be 50. So our number at the end over here is going to be 53. And so the two numbers that we added that were maximal were 7 and 53. And this is going to give us a total of 60. And that is our final answer. So hopefully this makes sense to you guys, but when you want to double the range and add maximal things, so yeah, the last concept that we went over, minimality and optimality, this comes into play a lot of times when we're talking about mean, median, and range, mean, median, mode, and range. So the final answer is going to be 60, and yeah, it's going to be really important that you guys figure out how to do all of these things when we have mean, median, and range involved. Because really important, a lot of people would say, oh, well, we can make this 8, but actually that's not the case because you need both the mode and the median to stay the same. So yeah, hopefully that problem shouldn't be that difficult though. And the crazy thing about that problem is that it's actually a problem 20 in the AMC 8. So really, really difficult problem that we just did together. So yeah. Now, next thing we're going to be going over is a very broad topic called logic in general. Okay, so logic is not something easily taught. You have to understand reasoning well in order to figure this out. So I think I'm going to skip this first problem that we're doing, and I'm going to go on to the second problem because I want to do this problem more than the other one. So a Königsberg school has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by hallways as shown in the figure. The school notices that each pair of connected pods has been assigned grades differing by 2 or more grade levels. For example, grades 1 and 2 will not be in pods directly connected by a walkway. What is the sum of the grade levels assigned to pods C, E, and F? Okay, so this seems really difficult, right? Because we have a bunch of different things, and there's nothing very certain that has been told us by the problem. Like, they didn't even give us the answer to any of the pods in particular. So we're kind of in the dark right now. But one thing I do notice is that 1 is connected to 2, 2 is connected to 1, and also connected to 3. And what I mean by connected, I mean like adjacent. So when the number is adjacent to another number, that means that it can't be next to each other. So 1 can't be next to 2, 2 can't be next to 1, 2 can't be next to 3, 3 can't be next to 2, 3 can't be next to 4, 4 can't be next to 3, and so on and so forth. And what you notice is that 7 and 1 are unique in this problem because they only have one number that they can't be next to, whereas everyone else, every other number, has 2 numbers that they can't be next to. So I want to see if I can use that at all. And what I noticed is that C has 5 connections. 1, 2, 3, 4, 5. And that's the same thing with F. F also has 5 connections. 1, 2, 3, 4, 5. So that means that both these numbers have 5 numbers next to it that it could be next to. And it has 5 numbers that it differs by 2 or more by. And the only 2 numbers that satisfy this are 7 and 1. 7 and 1. So let's just put those 2 numbers there like that, and maybe that's not how it actually works, but we'll see later. So since it since this C has 5 neighbors, that means that this G over here is going to be the one that can't be next to the C. So that means that this G is going to be 2. And same thing with this D in relation to the F. This is going to be the 6. Okay, so now we need to figure out some more things about this problem. So E over here cannot be 5. E has to be 4 or 3. And A over here cannot be 3. A has to be 4 or 5. And B over here doesn't really have any particular restrictions as of now. But we do know that A and B differ by more than 1. So since 3, 4, and 5 are our only numbers, we know that 1 has to be 3 and 1 has to be 5. More commonly, A has to be 5, B has to be 3, and that means that this E has to be a 4. So 1 plus 4 plus 7 is C plus E plus F, and our final answer is going to be 12. So yes, I really like this problem because it seems really difficult at first, because all you have is all these things and one simple condition where none of the grade levels can be different by 2 or more. So there's not very many distinctive things about this problem, but once you start solving it, you realize that the answer is going to be 12 because you can figure out that C and F are 1 and 7 respectively, and the problem just goes from there. So yeah, that's really, really cool. And now, earlier in the workshop, we talked about easy equations, which was just general, like reading of word problems in general and assigning variables to values and figuring out problems like that. So now we're going to move on to hard equations. And this is pretty much the same thing. There's going to be a lot of word problems that we're going to be covering and also actual equations like this. So this is just like the general throw-all basket of algebra problems that's you're going to have to use some creativity and be careful with. So our first question is x squared minus 5 squared is equal to 16. And how many different real numbers satisfy this equation? So the very interesting thing to think about is that we can't just take the square root of both sides. And the reason why we can't just take the square root of both sides is because if this entire thing is equal to negative 4, then we also get 16. So we know now that x squared minus 5 is equal to negative 4, or x squared minus 5 is equal to 4. So that means that x squared, in this case, x squared would equal 1, and in this case, x squared would equal 9. So now, from this, we get x is equal to plus or minus 3, positive or negative 3, and x squared is also equal to positive or negative 1. So we get 4 different equations that satisfy this. Alright, so I went through that problem pretty quickly, but hopefully you guys understand. The most important thing to realize is that when you have a squared, it can be negative or positive. So we have x squared and this inside thingy, and it can be negative or positive. This x squared out here, this entire expression can be negative or positive. Alright, Jordan owns, let's move on to the next problem now. AMC 8, 2024, problem 19. Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red and the rest are white. 2/3 of the pairs are high top and the rest are low top. The red high top sneakers make up a fraction of the collection. What is the least possible value of this fraction? Okay, I'm going to draw a thing called a Venn diagram here. Yeah, a Venn diagram is really, really useful for the specific thing. But you don't necessarily have to think about it like this. There's a lot of different ways to think about it. So 3/5 of the pairs are red. So let's say these are the red shoes and these are the high top shoes. So if you don't know what a Venn diagram is, this is going to be all of the red shoes. This circle is going to be all the red shoes. And then this circle is going to be all the high top shoes. And then this inner region intersecting is going to be the amount that is both. So we want to make it so that this area in the middle is this value in the middle is going to be as low as possible. So we have 3/5 over here, and we have 2/3 over here. So that means we have 10 shoes in the high tops and 9 shoes in the red. So 9 plus 10 is equal to 19, which is greater than 15. So we can't just have 9 reds and 10 high tops and then have 0 reds and high tops. So we need some amount that are red and high top. So what we're going to do is we're going to make it so that there's some amount of reds over here, some amount of intersection, and some amount of thing over here, and they're going to add up to exactly 15 because we want every single sneaker to be red or high top or both. And because if we're doing sneakers that are white and non-high top, we could just be using those sneakers to help us maximize the least value of this fraction. So all of our sneakers are going to be red or high top or both. So in order to decrease this number, every single red high top sneaker we put decreases this number by 1. So basically we need to put 4 as our red high tops because then we get a 5 over here and then a 6 over here. And 5 plus 4 plus 6 is equal to 15, just like we wanted. And the reason why we put this 4 here, what we knew, is because 19 minus 15 is equal to 4. And we were 4 over, so we needed 4 sneakers to do like double duty, I suppose, and be like, I am both red and high top. So then that is 4 is going to be our final answer. So those are some pretty difficult problems. Problem 20 on the AMC 8 and problem 19 on the AMC 8. But hopefully you guys should understand that it's a lot of just interpreting what the words of the problem say and stuff like that. So now we have 9 minutes left. I think we're going to go over some coordinate plane problems. I did have some harder problems at the end, but I don't believe we will have time for that. So we'll just go over this and then we'll be done for today. But if you guys have any questions or are struggling with anything, if you guys could say that in the chat below, that'd be really nice. If not, then you can type good or something of that sort, just to tell me that you're still here and listening to me. Alrighty. Okay, we're going to move on to the coordinate plane now. So the coordinate plane is, hopefully you guys should have heard of this before. It's something that's like y equals mx plus b is the common equation of a line in the coordinate plane. So y equals mx plus b, and the coordinate plane frequently shows up on the AMC 8. And you can sometimes utilize its coordinate geometry. You can utilize something called coordinate geometry to solve these kinds of problems. So it kind of looks like it's geometry, right, this last problem that we have here, but actually there's a very algebraic thing that we can do to solve this. Let's just jump into the first problem, and yeah. So Rodrigo has a very large sheet of graph paper. First he draws a line segment connecting point 04 to point 20. So that would look something like this. 04 to 20. And colors the 4 cells whose interior the segments as shown below. So basically what the drawing is showing is there are 4 cells that this line touches. And these 4 cells are going to be right here, like as I've shown. So the 0, 4, and then all the way to the 20. So these are the 4 cells that we touch. And then what we need to do is, next Rodrigo draws a line segment connecting points 2000 to, point 2000, 3000 to point 5000 to 8000. How many cells will he color this time? Okay, so we start at 2000, 3000, and we go all the way to 5000, 8000. And we need to figure out how many cells we're going to color this time. Okay, so let's think about this. 2000, 3000, and we go to 5000, 8000. Okay, so every single time we cross a line, we color another cell. So we're going to cross 2000, 3000, 5000, 8000. We're going to cross 5000 lines horizontally, and we're going to cross 3000 lines 3,000 lines horizontally and 5,000 lines vertically. So basically what I mean by this is, think about it. We have one line here, and when we're crossing it, we're making a new line. We're entering a new region every single time. The only caveat to this is that sometimes we hit like corners of the cells, right? Sometimes we hit the corners of the cells, in which case we cross both a vertical and a horizontal line at the same time, and we can't just keep on adding like we did before. So 5,000 and 3,000 are how many lines we're going to cross, and we need to add them up to figure out the answer to this problem. However, this is not going to be necessarily the answer, because we have sometimes where we hit both the corner of both of these. So that happens when we are on an integer coordinate. And now this is pretty confusing about when this is going to happen, but the slope of our line is going to be change in y over change in x, or 5 over 3. So every third time that we hit a y equals 5/3 x plus something, every third time that we hit an x line, so that would be like one of these lines, and we do that a total of 3,000 times, every third time it's not going to count. So that means that our final answer is going to be 1/3 of these times is not going to matter, and this means that we have 5,000 plus 3,000 minus 1,000, and this is going to be a final answer of 7,000 total times that we total cells that we color. So that problem is very difficult, but hopefully you guys got a little bit of a grasp of how that works, and if you don't, that's okay. So we've advanced problems also here, and if you need to, you can look at them for a second, but we're not going to go over them today because we don't have very much time, and yeah, we are running out of time, so I'm going to end this a little bit early today actually, because we don't have enough times to solve any of those other problems. But if you want to know how to continue practicing for the AMC 8, then you can contact me for more tutoring like this. And yeah, I do one-on-one tutoring for $30 an hour. You can email me at this email if you want to. I really like teaching people individually, which is a really, really great thing. So if you want to, you guys can reach out for me for more things like this. But if not, yeah, if you have any questions, you guys can ask them to me now. But if not, you guys are free to leave. So thank you so much for coming, and hopefully we'll see you next time at the next workshop. You're welcome. See you later.